Assalamualaikum and good day everyone. So let's continue. We're still on compressibility and consolidation, and we're talking about coefficient of consolidation C sub V. Alright, previously I have mentioned that Taylor's method is a method that measure the C sub V at 50%. So I would like to do some corrections. Okay. So C sub V for Taylor methods is measured at 90% of consolidation. So whereas for the Casagrande, it is measured at 50% of consolidation. So when at the end of the analysis of data, so when you able to measure the T90 or T50 based on the data from the graph, so you can substitute. Okay, so for the Taylor method, you will use the 0.848 time factor times with the height of drainage to the power of 2 divided to the T90 that you obtain from the graph. Okay, the T90 that you obtain from the graph. So whatever value that you got here, and you knowing what the unit of the drainage, if let's say if it is in the meter, so you can finalize the answer C sub V later in the meter per minute. Okay, because usually the graph for the C sub V graph is plotted sometimes in the millimeter, sometimes in millimeter, but usually for the time is in minutes. So you can obtain the C sub V meter or millimeter, depends on your results, per minute or per second. It also depends on your time that you use to plot the graph. Alright, so similarly for the Casagrande method, so we obtain the T50 from the graph, okay, based on the data from the laboratory. So the equation that you use, time factor T sub V here is 0.196 times to height of drainage divided T90 at T50%. Okay, so let's skip this one. I think you already understand this. Okay, noted that this is T50 if you use a Casagrande method. So we just read. So here maybe this is 10.5 minutes because this is log graph. So I believe 11 is here. So maybe 10.5 minutes. Okay. So let's see for the Taylor. Okay, in previous video, we already learned how to obtain the D90, degree of consolidation at 90%. So we can read for the T90 here. So this is, I think this is just a normal graph for Taylor method. So this might be, let's say this is 7.5, so maybe 6.8 or 7, okay, for the minutes. So we can substitute in our calculation. Let's say height of the sample is 20 millimeter. So therefore, height of drainage is 10 millimeter. 20 divided by 2 because we have a double drainage. So 10 millimeter to the power of 2. Substitute with the T90, it is 6.8 minutes. So you can calculate and you can get C sub V in millimeter per minute. Alright, make sure that you put the part to the power of 2 for the millimeter, okay, because we power the millimeter here in the height of the drainage. So your C sub V supposed to get some magnitude in millimeter to the power of 2 divided by the minutes. Okay. Alright, so we already see both of the method, the Taylor methods and also the Casagrande method. So why not we try one example of the Taylor methods. So let's try the example. Okay, so let's see this example. So this is final exam questions from session 2018-2019 semester 1. So this is the question. Calculate the time that it will take for 90% of consolidation. And determine the coefficient of C sub V based on the data given from the table here, table Q2B2. Okay, note that the marks is 10 marks. Okay, the marks is 10. To obtain the T90 and to obtain the C sub V, we need to plot the settlement curve. Okay, all right. So this is the data. Okay, the time in minutes, delta H millimeter. So noted that previously I have explained to you, sometimes the reading or the data are taken in the form of dial gauge reading without the units. Okay, but here it means that the dial gauge already times with the millimeter units. So now they give their reading in terms of delta H, the differentiate of the height, the differences of the height due to the loading pressure from the odometer test. Okay, odometer test. Odometer test is a consolidation testing to obtain the C sub V. Alright. The initial specimen height is given 17.53 millimeter. So what we need to do when we get the data first, okay, I'm using this side of PDF. So here you can see that I already calculate. Calculate the H minus delta H so that we can plot the graph. Okay, so that we can plot the graph. So here is the first one. Okay, initial height of the specimen 17.53 minus the 0.233 first differential of the settlement. So we get 17.297. So I put into the column. So we do the rest, the calculation for the rest. Okay, 17.53 minus 0.302, and then 17.53 minus 0.309 until the rest. Okay. Alright, so the graph that we use for Taylor is just a normal graph, okay, not like a Casagrande. So for Casagrande, we need to use this graph, but for Taylor, we just use a normal graph. So this is what the graph looks like that I halfly plotted of the points. Okay, note that you need to try and error to pick or to build up the axis size. Okay, so you need to scan first, skim and scan what the range of the delta H, H minus delta H that you need to plot. So we know that it is start from the 17 millimeter and the lower is about 16. So I try to include 16 to the 17.6, the maximum one. Okay, because the initial height is 17.53. So I put at least 17.6. No need to go higher. Included at least the initial height of the sample is already enough. Okay, but for the time, okay, in minutes, okay, note that the minutes actually cover up to 24 hours. Okay, cover up until to the 24 hours. Okay, for the Taylor, there's some tips. Okay, you doesn't need to plot the curve up to 24 hours. Okay, 1440. No. As long as you get the curve at the side of to draw the parallel line, so it is already enough. So what I'm trying to plot here, I already plot up to, I think, 4 minutes. Okay, 4 minutes. And we can continue for the 9, okay, for the 15, for the 30, for the 60 is already out of the bond of this graph paper. But at your home, you can rotate the paper graph and maybe you can plot up to 120. Is based on what you pick for the size of the axis for X. Okay. So let's finish the plotting. Okay, so at 9 minutes, we got 9 minutes is 16.56. So 16.5 using my scale, maybe some here. Okay, let me change the color, orange, okay. And then this is dotted that I provide for the 15 minutes, 30 minutes, and 60 minutes out of the graph paper, but it's okay. If you want to send a report to your boss, engineer, don't do like this. but this is for the sake for learning. I'm just use anything, any sources that I have here. So let's continue the curve. So it is a freestyle curve. So Bismillah. Oops. Difficult. Change the all color. It's okay. So another tips, when you want to plot the graph, okay, let's say here, make sure the dotted point that you you read for the data, you do the cross, not do small point like here. So when you do the curve, it cannot be seen. Sometimes it cannot be seen. Do the cross so that we lecturer, we can assess you, or you managed to plot correctly for the respective point. Okay. All right. So once we done do the curve, let's use red. Okay. So once we done do the curve, so refer back to our slides. Okay, we can refer back to our slides. That first step in the Taylor method, you need to develop the pink line, I think. Okay, pink line. Oh, and I change to pink. Change also to pink. How do we do this? Okay, so now we need to do note where is D at 0 of consolidation. Of course, at initial height of the sample D naught, D naught, degree of consolidation 0. So we need to do a parallel line. Okay, assume this is straight line. I try my best to draw a line digitally. So you might cross over here. So this is P point. So maybe for easiness, let us take P is equal to 10, right? So I hope you still remember, we need to obtain Q. Q is 1.5 times P. So times the 10, so we get 15, right? Okay, 15. So reread again. Okay, reread again. Okay, we read 15 at the graph. So this is Q point. So the Q point need to cross connected to the D0 point. Degree of, oh no, kind of fail. Okay, it's kind of quite tricky to draw using digital pen. Okay, all right. So I think that's a good one, maybe. So anything that cross the curve, okay, anything that cross the curve, let me try to change the color. Okay. So anything that cross the curve, this is the point of degree at 90% consolidation. So what just need to do is read the T90. So we obtain T90 for this data is at 6 minutes. So after this, substitute in the equation and you get the CV in millimeter squared per minute. So, okay, so you can finish up these questions. Until we meet again, so next inshallah we will learn about E-log pressure, CC, CR, and also how to obtain the pre-consolidation pressure. There's a beautiful story behind the pre-consolidation pressure, inshallah. Till we meet again, Assalamualaikum, bye.